So let's actually have a look at the pattern for cubics. So the perfect cube, a cubed, 3a squared b, 3ab squared, b cubed. The powers of a are going down by 1, the powers of b are going up by 1. The two powers always add up to be 3. And the coefficient of the pattern is 1, 3, 3, 1. When we later on we'll look at something known as the Binomial Theorem, and we actually can generate that to any power. The signs alternate, that's the only difference. So we go plus minus plus minus. If I was to generalise this one, a bit more interesting than the square one yesterday, every one will be cubed. I will get 3 times all the ones where one of them are squared and one of them are not. But we will also get 6 lots of all the possible triplets. So in this case it was A, B, C, but had there been a D there as well, I would have got 6 lots of A, B, D, 6 lots of B, C, D. I think that's it, isn't it? That's all the combinations, what have you. Difference of 2 cubes. A minus B, A squared plus AB plus B squared. You've got to be real careful with that one, because it is so tempting with that second one to go, oh, that's just A plus B squared, because we're so used to seeing A squared plus 2AB plus B squared, but of course it's not. It's A squared plus just 1AB. But for a cubic, we also have a sum of 2 cubes. We don't have a sum of 2 squares, but we do have a sum of 2 cubes. Again, you'll see a very similar pattern. It starts with whatever signs we're coming from. So if it's a difference, it starts with a difference. If it's a sum, it starts with a sum. And so then in the second one, the middle term, it's the opposite sign. Started with a negative, so we got a positive and so on. So 2a minus 5 all cubed then, if I was going to do it all in my head, I could write it all down straight away. But what I'm basically saying, okay, first term cubed minus 3 lots of the first one squared times 5 plus 3 lots of the first one to the power 1 times 5 squared minus the 5 cubed. And we end up with that. Sum of 2 cubes, if I had to factorise, that is, of course, x cubed plus 2 cubed. So we'll go x plus 2. Again, this is where you've got to be careful. Remember, it's x squared just minus the product, not twice the product, minus the product. So 2x plus 4. Difference of 2 cubes. Y cubed minus 27a cubed. 27 is, of course, 3 cubed. So it is, in fact, y cubed minus 3a all cubed. We get y minus 3a, y squared plus the product, plus 9a squared. In fact, you can generalise that one as well. A to the power of n minus b to the power of n will always start with a minus b. Always start. Then the second one, you just get the powers of a. Every term then just goes down by 1 until it comes down to a to the power of 0. And all the b's start at b to the power of 0, go up by 1. So the 2 powers always add up in that one to be n minus 1. N minus 1. Okay. Because x to the 5 minus y to the 5. So that would be x minus y, x to the 4 plus and so on. So powers of x going down by 1 and so on. A to the power of 7 plus 1. It's an odd one, so we can do it. Because what we're really doing is saying minus 1 to the power of 7. So rather than thinking of it as a sum, I'm thinking of it as a difference. I can do that with odd numbers. I can't do that with even numbers, because if I went minus 1, say it was power of 6, well, that's going to be plus 1, so it's not going to work. And so that's why we only have them for the odd powers. Which also then explains why we get the alternating. Because it's the minus 1 is to an odd power, it's going to be negative, even power, it's going to be positive, and so we get that alternating all the way down the pattern. All right, so I said it's not in the new syllabus, so consequently it's not in the new textbook, but we do have the old textbook still on Moodle. So we'll call it Old Cambridge. Exercise 1A is on the cubics. I still think it's a valuable thing to have knowledge of, because it will come in handy in some things, I'm sure, down the track.